Yeah, I will spend the rest of the time talking about uh, kind of an overview to AI and ML. So, what is AI? Well, AI refers to mimicry of natural intelligence using computer software. So, typical applications of AI, or let's say subfields of AI, are NLP, or natural language processing, speech recognition, and computer vision. So, ML, or machine learning, is a let's say it's a subfield of AI. So it's machine learning. It's about using algorithms to do statistical learning from data. So everything machine learning uses will be quantified. So even when we use words, those words will be turned into numbers through some kind of pre-processing technique, and then the learning algorithm will try to do predictions. So it will try to predict, for example, a class like positive, negative, or a value like excuse me, I have to. Nyt ei voi tulla. Okei, no tuu nopeasti. Mä tuon luento tässä. Yeah, sorry about that. I'm getting electricity readings. So yeah, or a value such as, for example, sales forecasting based on historic performance. What is the predicted sales for next year? So we will be talking about those. So classification is the name of the machine learning task when we predict a class, like positive, negative. We have two classes. It's a binary classification. If we have three or more classes, it's a multi-class classification. So one of those four, for example, happy, if a text is displaying some emotion like happy, sad, joy, something like multiple ones. So it predicts one of those classes, it's multi-class. If there were multiple possible choices, it's called multi-label classification. So sometimes you can have topics, for example, news topics, and you can have multiple topics simultaneously, like Finland, politics, center party. All those could be selected as being true for a given news story. So that would be multi-label classification if the algorithm can predict multiple classes simultaneously. So there are different machine learning tasks, and usually when we talk about AI in marketing and business, what we mean is applied machine learning. So applied machine learning is when we actually use these statistical learning algorithms for given tasks, like the ones I just explained. So this thing about AI and intelligence, it's kind of like a very esoteric, and I call it a little bit red herring. Red herring means something that is kind of misleading you. So we, from business side and marketing side, the question of if a machine really has intelligence or not is not that interesting and important. What we are actually interested in are the applications, and that's the applied machine learning part. So actually using these algorithms to carry out prediction tasks that have some kind of business value. So that's, I'm just mentioning it because there's a lot of debate on, okay, is it creative? Is it, this and that? But that's really not, that's an area that would be theoretical machine learning or theoretical AI speak. And it's less interesting and impactful than actually the applied machine learning. So in applied machine learning, we are predicting something. Well, that happens usually by, we have a loss function that will be minimized typically. And yeah, we deal with inputs and outputs so predicting some variables from those other variables. So a lot of the machine learning algorithms that we have, for example, regression, those are statistics algorithms or statistical equations. So linear regression that you would use to predict a value, like amount of sales in euros, and then logistic regression that you would typically use for binary classification to predict yes or no, or positive or negative. So those are very old statistical methods. It's just that now that they have been programmed into libraries in Python, typically Python is used as a language for this applied machine learning. So now they can be deployed in scale, and the models that we receive from those algorithms can be saved and reused for new data and can be implemented in real systems that can give predictions, right? So that's the sort of the new part in it, essentially. But also, of course, we have new algorithms like XGBoost or super vector machines or CatBoost, kind of more advanced algorithms for making prediction than the traditional statistical inference algorithms. So there's part new things, part old things when we talk about machine learning. But the foundation of it is in like statistics and statistical learning. And then intelligence was mentioned as a characteristic. So there are different ways to define intelligence, and basically the key insight here is that the models are good enough to exhibit as if they were intelligent, or exhibit intelligence or appear intelligent, right? So that means that especially now with generative AI, a lot of the tasks that only humans could complete using systems or making calculations, predictions, decisions can now be completed by these AI models. So that's sort of a practical approach to intelligence. So whether they're really intelligent or conscious, they are not, but they're mimicking humans good enough to perform decently at very many tasks that now can be automated using AI technologies. So again, that's why I'm saying that the general intelligence, artificial general intelligence, or AGI, you hear a lot debated in the news and media, and also by business people who really lack understanding of, like, as I mentioned, ML basics, but they are interested in this big topic or debate. It's really not that interesting and really not that impactful, because we can see that many of the tools can be used to create value. So we should direct our attention to that question and ask, how will AI be valuable in business and marketing applications, rather than debating senselessly about whether AGI exists or not. So that's my opinion, and sort of a tip to you that focus on those discussions about AI that talk about the applications and value rather than debates on the AGI, because it's very, very kind of philosophical and not that practical. So automation is a typical machine learning use case. So when we make those predictions, then we might connect to other systems to make decisions, and automatic automation. We would have triggers like sending emails or pausing campaigns or increasing budgets, or those kind of or flagging something that requires human attention, monitoring anomalies, things like that, alerting people. So this can be a helpful tool, again, to automate some of the routine tasks in marketing, but also to be used in a way to flag things that a human's attention is needed. So automation is a very typical machine learning use case, and then it means that we have some model and it's implemented in some system, and then it runs there and it gets input data and it gives output predictions, and those predictions are connected to some other algorithm that is then doing something. So it's never only just one AI. Every system consists of multiple algorithms that use multiple libraries, multiple logics, and the whole thing is a combination. So AI is not just this one thing that is now magically doing something. So it's one component, it's literally one model that's just taking some input that has to be in predefined structure, and it gives an output that also has to be predefined what it gives as an output, right? And then whatever happens after that, we need to build a new system, new algorithm that does something based on the prediction. So again, this is to steer your attention away from thinking that this is some sort of magic and it's some sort of automatic thing that now AI is taking. No, everything is built by human developers, and everything can be built in sort of any way. If we don't build connections, what we get from AI is just a series of numbers, and nothing will happen. So literally, if we want things to happen, we need to build everything and design everything. So this is how the companies like Google and Meta and others are working. So they are building those systems that use hundreds of different models at different stages of to complete different subtasks and predictions, and then those are tied into some other algorithms that then do something else, and so on. So it's about systems, and yeah, so not all automation uses machine learning. There are also rule-based. So for example, you can set thresholds that if the number of orders decreases by 15%, notify me, right? So this is called heuristics, and this is how automation used to work. Machine learning would be different in that we would not set necessarily thresholds, although we could do that as well, and some parts of machine learning require us to do some kind of manual thresholds like hyperparameter optimization. But predominantly we would give more of a question that is more of an open-ended question, like predict if this customer is likely to churn, meaning that if they're likely to stop being our customer. So then we give a lot of futures. In machine learning, variables are called futures to this prediction algorithm, and it will predict for a lot of customers, yes or no, they are likely to churn. And then we test it using real data where we know the answer of what happened, yes or no, for the customer. And then we see how accurate it was in the prediction. Okay, it was 90% accurate, so 9 times out of 10, it's correct in predicting if a customer will churn or not. So the difference is that now we are getting a prediction, and it has always some error rate, and then a prediction, whereas in rule we sort of always get the same answer with the same data. So a rule is deterministic and prediction is very much well, it can actually, the prediction algorithm can be deterministic, so you always get the same answer with the same data, but let's say it's erratic, it has some imperfection, whereas a rule runs sort of always the way we were intending it to run. So we now are making a trade-off between how much we want to set rules, manual rules to run the business and make the decisions, versus how much we will use sort of predictions to run the business. And then also in this case of when we're using prediction, for example, doing classification, the negative or positive sentiment of customer message to us, we are defining those classes, positive, negative, right? So the AI will not magically start to destroy the planet. It just simply outputs the probability for or confidence for the class yes and the class no, and it will do nothing else. So we are actually very much in control when it comes we as humans when it comes to this applied machine learning. So the things about the talking about AI taking over the world and so on, that's another thing that's sort of kind of quite disconnected from the reality of using these technologies in businesses. It's very much more constrained, and we have a lot more control in navigating this using these models in practice than what you would think based on what the media is reporting. And yeah, the automation in marketing, we can sort of view it in a broad and narrow way. So marketing automation was heavily commercialized as a term by the company called HubSpot, which is a B2B sales company that is selling this marketing automation software. So it almost shrunk the concept of marketing automation into meaning sending automatic emails, right? Automated emails to people. So that's how some people actually understand only marketing automation to be automatic sending of newsletters or personalized emails. So that's a narrow view. The broader view of marketing automation is basically that every activity that marketers do could be subject to automation. So then it's much more, it's not only about newsletters and designing those kind of automation workflows for newsletters, but it's about every activity that we do. Like if we are writing ad copy text, sometimes I write in different language because I operate a Google Ads account in a different country. So I use ChatGPT to automate the writing. So it does automatic translation, but sometimes I just give it a tell about this thing in my target language and it will output. So what I'm saying here is that as marketers, we can be sort of creative in coming up in using the automation and machine learning tools to support our work, and all those small gap tasks and activities, that's also part of marketing automation. And when we think of it more broadly like this, it's more productive, and we can try to define more use cases for marketing automation than just sending those automated emails. Yes, so here's an example of a neural network. So neural network, also this is what you often see when they talk about AI. So neural networks are just one type of ML model, and there are a lot of other models. And technically speaking, neural networks are a model architecture. So it means how we set up the learning algorithm. And in this structure, you have the neurons, and then you have the weights and the connections between the neurons, and you have layers. So input layer contains quantitative representation of the data. So it's called the future representation. So futures again are variables, and you have a variable like gender with male and female and non-binary. So you cannot put those directly into a learning algorithm. You need to first transform them. So you would do, for example, one-hot encoding. So you have a separate column for male, and it's 0 if it's not a male. If it's a female, that column will have 1. Non-binary will have 0. So this is called one-hot encoding. In some way, you will transform all your data from categories or other types into numbers, and those numbers will be then fed. So this is called pre-processing, and those will be fed into a learning algorithm. And in neural network is one of the learning algorithm architectures that then uses different algorithms like propagation and gradient descent to do the actual learning. So it would have all neurons are connected by these linkages, and then all of them have weights, and then it's in output layer it gives a prediction. So basically it can have multiple hidden layers. Here is just one, but it can have multiple layers. That's why we call that's called deep learning. If you have multiple hidden layers, the more hidden layers you have, the deeper the network is. A shallow neural network like this only has just one hidden layer. So typically those image and vision-based models have multiple layers that sort of gradually form an abstraction of the image, and then overall the network will give sort of a correct prediction, like is the picture man or a cat or whatever are the options that we're giving. So basically it's trying here, always in learning stage, we give it that, okay, this image is a cat. So we give it 50 images of a cat. So now it's like trying to update all the weights here automatically to correspond with the solution that it's a cat. And then the same for man and the same for car. So it's trying to learn a solution where these weights are adjusted so that it can separate between cat and a human. And that's what the learning is doing, and that's what the algorithms like backpropagation and gradient descent are doing. So yeah, in practice, when we do machine learning, neural network we would consider it as one algorithm to test, and then we could have others like XGBoost or super vector machines or logistic regression, depending on the prediction task that we're doing. So different algorithms work for different prediction tasks, but neural network is an example that pretty much works with anything. It works with regression, classification, and so on. So some algorithms sort of work with multiple or all types of prediction tasks. So you would compare their performance on the test set, and then you would say, okay, yeah, neural networks had an accuracy of 95% and XGBoost had a 90%. So yeah, neural network is better. So then based on this experimentation, we would optimize the neural network even further and then save it and then shift it to production. So this is how typical sort of machine learning pipeline or process would work. So yeah, we have interesting ideas. So previously there was a shift called software is eating the world. This was a famous essay by venture capitalist Mark Anderson from Silicon Valley back in 2011, that every company needs to become a software company. And it was pretty, yeah, it's considered classic because really it's a powerful thing. Software transformed pretty much everything, and software companies are the most valuable companies in the world at the moment. And yeah, it's just yeah, it's just true that, you know, with digitalization, everything required software, and software companies became really the leading businesses. And then software ate the world. Now AI is eating software. This is an interesting twist to it that's relatively new. And it's also true in the sense that finally sort of the value of AI technologies are becoming prominent. So AI, the concept was invented in 1956, and it was based on this idea of trying to simulate human intelligence and mimic it. But unfortunately, computational resources, and we didn't have digitalization, we didn't have the computer power, and we didn't have the infrastructure to run to create real AI. So that then led that there was a hype cycle of this concept until the 70s, but then there became AI winter, so people lost interest in it because there was not really a major groundbreaking breakthroughs happening. So, but then there were new inventions, and I think something like neural networks and something like that. Again, something happened that invigorated interest. But again, no breakthrough. So second AI winter happened in the early 90s. But now in the 2000s, a lot of the bottlenecks have been resolved. Computational resources no longer an issue. The finding the correct learning algorithms no longer an issue. Data being available through digitalization no longer an issue. And then systems being connected, yes, we have API technologies. So systems pull data and communicate with one another. This infrastructure didn't exist prior to digitalization. So no longer an issue. And then open source software needs to be mentioned because it plays a huge role in this. So if you'll do, like we'll do in practice sessions something, so we'll use ChatGPT to generate some code, and then we'll run it in Google Colab, and we'll use open source libraries like scikit-learn, which is people for free have developed you this software that you can use to run the same machine learning algorithms that people at Google do, like for free, which is just amazing. So we can do similar stuff that they do that have been developed by sort of a genius level people and are giving that tool for free. So this democratization of data science tools and algorithms is driven by this open source ideology. It's a major contributor. And many of these companies are using those same tools, and also some of them are contributing back to developing those tools even further. This is very important. So here are some milestones about AI. I mentioned AI winter, but yeah, you can see Siri coming in 2011 already. Alexa 2014. Microsoft had a chatbot, and just it's not so long ago. Well, 8 years. Time is going fast, but they had this chatbot Tay, which kind of at that time people thought there will never be a chatbot that works in the wild because Tay was corrupted and started um, sort of going off rails very strongly, and it was pulled off, and it became like a classic embarrassment of chatbot technology in the wild, which is one of the reasons why companies like OpenAI have strong guardrails in terms of what the AI can say to avoid any kind of hate speech and stuff like that. So these guardrails were inspired by previous successes and failures, especially the failure of this Tay. And then with the deep neural networks, AlphaGo was 2017. Here's another historical look into different technologies. So those commercial tools are one thing that we see as consumers and marketers, but then behind this are all these heroes who have invented the algorithms and the models and the model architectures that have enabled these innovations. So something comes up, someone develops a new idea like convolutional neural networks by LeCun, who is working at Meta uh, as an AI scientist. So he comes up with it. He shares that with other researchers. Someone goes ahead and programs it, and now it becomes part of the free open source movement. And then thousands and thousands of scientists and researchers across the world start using it, and then they develop it further, and then companies also pick it up and start implementing stuff. So this cycle of innovation is happening like that. And the latest, of course, one of the biggest ones in recent history is the transformer architecture that was developed in 2017. And for example, ChatGPT is based on the idea of transformers. So yeah, this there's a long historical tradition in this technological development. So for marketing, basically, if you use a Google tool like Google Ads, or any tool, AI has already crept in. So a lot of the stuff it does under the hood has been automated, and you will actually never know it, because if you start using it now in 2024, you cannot see the history. For example, I started using it in 2009, and I can like see the change from then, when we did a lot more things manually, from keyword selection to setting bids on individual keywords and writing the ads and selecting and setting manually checking the goal reaching and stuff like that, which a lot of it has now been automated. So it's gradually creeping in. These technologies are being implemented into marketing tools, and this is good and bad. So now you will not get to experience all the stuff that we did back in the day manually, but on the other hand, you don't need to, because now the AI models are taking care of those functions. So now your activity and your value added will be focused on different activities when you're using these marketing tools. And yeah, so algorithms are implemented in interactive systems, for example, Google Ads, and everything runs on the web infrastructure on the cloud. So you can access it using any device anywhere in the world. So this means that really AI has been already put into production at scale, and millions of people are using on the consumer side for sure, but also on the business side and professional side. So a lot of it is already out there. It's already has changed changed marketing. So for example, in Google Ads, this is kind of similar, like a mock-up. So we just work with systems like this, and if they have keywords might have been selected by AI. The campaigns targeting might be based on AI, and we can do some things. We can do decisions here. We can do tweaking and tuning and adjustment. We kind of collaborate nowadays with AI. For example, when we run marketing tools and platforms like Google Ads. So it's no longer just a human work, it's a hybrid work. It's joint decision making, and our decisions are all the time narrowing down a bit. And we'll discuss that also in the course, the upcoming lectures, what it means. Another example is recommender systems. So basically, if Netflix is a classic example, Amazon another, but also we can view all social media feeds as recommender systems. This is a classic thing because there's an abundance of choice candidate items that could be recommended for a person to a person, whether it's movies in Netflix, or music in Spotify, or products in Amazon, or search results in Google, or in your Facebook or Instagram feed. What are the posts you see and in what order? So these are all problems that can be tackled by recommender algorithms that deal with how to select candidate items specifically for you, and then how to rank them in an order that you find most likely appealing. So yeah, these recommender systems and recommendation algorithms is one major area where AI and marketing are coinciding. There are, according to DAO, there are 12 families of AI use cases. And so there is prediction, autonomous systems, planning, decision intelligence, recommender systems, segmentation or classification, intelligent automation, perception, anomaly detection, conversational user interfaces, so typically chatbots, content generation, and knowledge discovery. So I think this is a pretty good taxonomy in about all possible use cases. There are many taxonomies like this, but again, I think this one is pretty good. Of course, many others are good as well, but it illustrates, yeah, that there's extremely broad applicability in the applied machine learning models in different domains of human activity, and marketing is especially so, you know, conversational chatbots, customer service bots, everyone has used them. They are still, in my opinion, a little bit useless, but they are getting better. Content generation, that's obvious. We can generate blog posts and ads and imagery for our ads. McDonald's Japan generated a whole video using AI, video ad using AI, and so on. The production quality is all the time increasing, and it's challenging human capabilities. And yeah, segmentation, marketing segmentation, customer segmentation, and so on. So we can find marketing applications in all these use cases of AI. But the important thing is sort of to avoid the tool fallacy and the focus on tools, and instead focus again on the value. So this is from Andrew Ng, who is a major deep learning expert and machine learning educator. So yeah, this is a good quote. I think when he's meeting the companies, you need to start from the problem. What is the business problem? And what are the issues before you go into the tool? So you shouldn't be pitching that, oh yeah, XGBoost can do this and that, and our algorithms can do this and that. But actually, this is just like any other, let's say, marketing activity where you start with the customer need and customer understanding. So this is the real thing, and this really helps avoid the veil of hype, because when you go and talk about the problems and you see the actual problems, then given that you also know the technology, you can try to find the match between the problem and an AI tool or technology that we can possibly use to solve that problem. So after that, we would do proof of concept to show that there's a preliminary solution, the technology can solve it in controlled settings, and then we would implement that in production if the result is good. And then we would need to monitor the solution's performance over time and improve it if we need to retrain the model and so on. So you can see that we are approaching computer science. So as marketers, we need to be willing to learn new things, right? So we need to try to understand, even if we just do marketing. For example, how does Google rank advertisement? How does it choose advertisement? And the same with organic results. So there are computer science formula and algorithm behind all these decisions. Every time you run a search in Google, it's arranged according to an algorithm. So we as marketers need to have some basic knowledge of how those algorithms work, because that can help us to, of course, take actions that improve our probabilities of ranking higher. And then another thing is computational thinking, which I'm sort of advocating as a blue ocean for marketers, because most often marketers lack in this type of idea. They are not able to specifically express themselves. They are not very good at splitting big problems into smaller problems. They don't understand the importance of precision and giving specific instructions, being very specific in your communication, in that your message can only be understood in one way when you work with colleagues or when you are doing some kind of development of a product. So this area, computational thinking, is what is sort of like a superpower and transferable skill, because once you understand that, then you sort of understand, oh, this is how computer science works, this is how algorithms work. Every technology is built on this foundation of us being precise and specific in giving instructions to the machine. So if we are able to communicate precisely, we are able to build basically whatever we want using these technologies. But if we don't specifically, if we're not able to express our requirements, then nobody will be able to build that. Another human or machine, they will not able to execute. So it's all about us thinking clearly and expressing ourselves in a computationally effective manner. So this is becoming a thing because marketers are nowadays competing with computer scientists and people with computer science training for jobs. I remember running Aalto University, the information technology program summer school. I had a module there, and one of the students said that, oh yeah, she applied for a Vault internship, and there were 6,000 applicants, and a lot of them had programming experience, like something R or SQL or Python. So I mean, and it was a business analyst position. So it's a position where a marketing student could apply. So a lot of the stuff that you would do in companies would now be like a business analyst position or something similar. So the line between a data scientist and business analyst is blurring because these tools and technologies are becoming more accessible for business people. It's easier to learn. The systems are better. They're more integrated. So these kind of basic skills that you need to be competitive in job market are shifting upwards. But the good news is that that leap to learning them is becoming easier. That's why the shift upwards is happening, because you no longer need computer science degree to be a proficient or be knowledgeable about SQL. You can run SQL now with the help of ChatGPT, and you can do it faster than someone who is trained in SQL. But you need to first understand what SQL is, what it's trying to do, and you still need to have that foundational knowledge, because otherwise you don't know what you're doing. And that's the catch-22 or the chicken and egg problem. That's why these kind of courses are important, because through this you can get some foundational knowledge, then that hopefully will help you develop um, your thinking toward using these tools more appropriately. So definitely new skills are needed and new tools. So Python and SQL would be two number one technologies. So for marketers, it's no longer Excel is enough in modern, platform economy and international job markets. You have to move a notch up from Excel. Excel will not be a competitive factor. But nowadays you can, by the way, run Python in SQL, which is also an interesting evolution. But anyway, the point is that you need to have uh, new skills, and you also need to have basic understanding how algorithms and machine learning works, especially if you want to contribute into system development, software products, analytics products and stuff like that. You need to be knowledgeable about basic algorithms. And yeah, a lot of new job titles and tasks are emerging that are now made possible and make sense within this digital environment and context. And also human-computer interaction is important, I want to mention. So HCI, this is about user experience and design. So that's another area that sort of, HCI is a subfield of computer science. So all the user studies and user research fall under the HCI umbrella. Other computer scientists usually don't care that much about these, but HCI is the field that cares, and that's why HCI is overlapping a lot with marketing. When they talk about users, marketers talk about customers, but both are keen on understanding these people. So this is a very important area in addition to the hardcore technical skills that are needed. And yeah, that's it. We are now out of time, so I want to thank you for participating, and see you guys on Friday. Hope to see you there, and have a good week.
Thank you.